Hello my students, in this video we will focus on methods of integration. There are several methods to change integrations that are not on standard form to be in standard forms. And as we have studied before in the previous videos, if we need to integrate sum or difference of two functions, we need to integrate f of x plus or minus g of x dx. So in this case we are going to distribute the integral. This is going to be integration of f of x plus or minus dx plus or minus integral of g of x dx. Then easily we can find the antiderivative of f of x with respect to x and g of x. But as we have studied before in the previous videos, that we don't have a product rule or quotient rule in the integration like the derivatives. For example, if we need to integrate a product of two functions, f of x times g of x. If we are going to distribute the integral this way, actually this is totally wrong, because the integral of f of x times g of x not equal integral of f of x dx times the integral of g of x. And also in the quotient of two functions, f of x over g of x, the integral of the quotient of two functions not equal the integral of f of x over the integral of g of x. So we are not going to distribute the integration in the case of product of two functions or the quotient of two functions, because as we have studied before in the previous videos, that we don't have a product rule or quotient rule in the integration like the derivatives. So the question is, how can we integrate the product of two functions or the quotient of two functions? So in this video we're gonna learn some techniques or some methods to solve the integrals or the product of two functions or the integrals of quotient of two functions. And the most common method that we are going to learn today is the integration by substitution. The integration by substitution or the substitution method. First method, the integration by substitution. Or we can call it U substitution. U substitution. So today we are going to learn how to integrate by the substitution method or by U substitution method. The given integration is given in the form of integration of f of g of x times g prime of x dx. F of g of x, or we can say f power n g of x, it's a composite function, times g prime of x. So actually we have a product of two functions. It's a product of two functions. But in this case, we have a composite function and the inside function multiplied by the derivative of the inside function. So the first function multiplied by the first derivative of the inside function. If we find this case, so we are going to apply the U substitution or the integration by substitution method. So if the given integration is given in the form of integration of integral of f power n g of x times g prime of x, which is the inside function, is multiplied by the first derivative of the inside function. So in this case, we are going to use the substitution method. We can say g of x, we are going to replace g of x by u. Then how can we integrate this form? If we find this form, so we are going to apply the integral power rule. So this is going to be f power n plus 1 over, we are going to add 1 to the power of the outside function over the new power, which is n plus 1 plus c. So you have to remember this form. And also if the given function or the given integration contains the nth root of a function, for example nth root of g of x. So also we can use the substitution method and we are going to replace g of x by u. Okay, let's see some examples in this method. Example 1. If we have a product of two functions and we need to evaluate or integrate the below function, 3x squared times x cubed plus 2 whole to the power 6 dx. If we need to integrate the below function, we need to find the antiderivative of 3x squared times x cubed plus 2 all to the power 6. So here we have a product of two functions. Here we have a product of two functions. So we need to apply the substitution method. So we are going to replace one of them by u and the other by du. Because if we have the integration of u du, so easily we can apply the power rule of integration, which is this is going to be u power 2 over 2 plus c, or we can say u power n, it will be n plus 1 over n plus 1 plus c. So we need to replace this example, this problem, to be in the form of u du, in the form of u du. So first we need to identify u and du. We need to identify u and du. If we select u to be this inside function x cubed plus 2, so easily we can find the derivative of u du, which is a differential function of u. So easily we can find the derivative of u. The derivative will be 3x squared. Derivative of u is du. It's equivalent to 3x squared. So if we make u x cubed plus 2, so du should be 3x squared. So we are going to replace x cubed plus 2 by u. So we are going to replace x cubed plus 2 by u. But du is equal to 3x squared. Don't forget dx. Du is equal to 3x squared dx. Here I need you to concentrate with me. We need to find dx, because we are going to replace dx by du. But we have a coefficient. Dx, if we divide each side by 3x squared, then dx is equal to du over 3x squared. Du over 3x squared. Then the integral of 3x squared, now we can replace u by x cubed plus 2. We select u to be x cubed plus 2. So it will be u power 6 times dx. And we are going to replace dx by du over 3x cubed, because we are going to apply this rule. So we need this problem to be in terms of u, only. Then we have 3x squared over 3x squared. So easily we can simplify 3x squared with 3x squared. Then Now the new form will be the integral of u power 6 du. So easily we can apply the power rule and we can integrate according to this rule. So this is gonna be u power 7 6 plus 1 over the new power, which is 7 plus c. And then don't forget, we are going to replace again u by x cubed plus 2. So it will be x cubed plus 2 power 7 over 7 plus c. And this is the final answer. This is u substitution method. I think it's very easy method. Let's see example 2. If you need to evaluate the integral of 4x x squared plus 5 dx, x squared plus 5 all raised to the power 3 cubed dx, the integral of 4x times x squared plus 5 all cubed dx. Again we have a product of two functions, and as we have studied before, we don't have a product rule in the integration. Cannot distribute the integral to be integration of 4x times the integral of x squared plus 5 whole cubed. This is totally wrong. So we have to apply the substitution method. So we need to identify u and du. So we are going to replace this function in terms of u and du. If we select u to be the inside function of this composite function, so u it will be x squared plus 5. U is going to be x squared plus 5. Then the derivative of this u, x squared plus 5, is going to be 2x du is equal to 2x. Don't forget dx with respect to x. So if we make u x squared plus 5, then du, which is the first derivative of u, is going to be 2x dx. So you are going to replace x squared plus 5 by u, and dx by function in terms of du. Then we need to find dx. Dx is equal to, we can divide each side by 2x. Then dx is equal to du over 2x. So easily we can replace x squared plus 5 by u and dx by du over 2x. Then the integral of 4x, leave it as it is. Then u power 3 u cubed times dx, which is du by 2x. Then easily we can simplify 2x with 4x. X cancelled with x, 2, 1, 4, 2. Then we have the integral of 2 u cubed du. It's a constant, so let's move it to the front. Then 2 integral of u cubed du. Then easily we can apply this rule. So we have 2 u power 3 plus 1, which is 4, over 4 plus c. And also we can simplify 2, 1, 4, 2. Then this is going to be u power 4 over 2 plus c. And don't forget we are going to replace u in the last step by x squared plus 5. So it will be x squared plus 5 all to the power 4 over 2 plus c, and this is the final answer. Let's see example 3. If we need to integrate a function of x cubed times 2x power 4 plus 3 power 5 dx. If we need to find the antiderivative of x cubed times 2x power 4 plus 3 all raised to the power 5 dx. Again we have a product of two functions, and the second function is a composite function. So we need to find if this function is the derivative of the inside function or not. So we are going to apply the substitution method. U du is equal to u power n plus 1 over n plus 1 plus c. So we need to identify u and du. U is going to be 2x power 4 plus 3. Then easily we can find du, which is the first derivative of u. So it will be 8x cubed. 4 times 2, 8x cubed. dx, don't forget. Then we need to find dx by dividing each side by 8x cubed. Then dx is equal to du over 8x cubed. So we are going to replace 2x power 4 plus 3 by u and dx by 8x cubed. Then the integral of x cubed u power 5 du over 8x cubed, and easily we can simplify. X cubed cancelled with x cubed, and let's move 1 over 8 to the front, then 1 over 8 times integral of u raised to the power 5 d. So easily we can apply this rule. Then this is gonna be 1 over 8 u raised to the power 5 plus 1, which is 6 over 6 plus c. So it will be u over u power 6 over 48, 6 times 8 plus c. And in the last step we are going to replace again u by 2x power 4 plus 3 power 6 over 48 plus c, and this is the final answer. Example 4. If we need to integrate x times x squared plus 1 all to the power 5 dx. Again we have a product of two functions, so we are going to apply u substitution. Then we need to identify u and du. U is going to be x squared plus 1, and du the first derivative of u, which is 2x dx. Then we need to find dx, which is du over 2x. Then we are going to replace u. We are going to replace x squared plus 1 by u, which is u power 5, dx, which is du over 2x. Then easily we can simplify x with x, and let's move 1 over 2 to the front, so it will be 1 over 2 the integral of u power 5 d. Then easily we can integrate this function by u substitution, so it will be 1 over 2 u power 6 over 6 plus c, and we are going to replace u again by x squared plus 1. So finally we have x squared plus 1 power 6 over 2 times 6, which is 12, plus c. And this is the final answer. Example 5. We need to evaluate the integration of 5x times 8 plus x squared all to the power 4 dx. We have a product of two functions, and the second one is a composite function. So first, we are going to apply the u substitution method. So we need to identify u and du. U is going to be 8 plus x squared, and du is the first derivative of u, which is 2x dx. Then dx is equal to du over 2x. So we are going to replace 8 plus x squared by u. It will be 5x u power 4 du over 2x. Easily we can simplify x with x, and we have 5 over 2. We can move it to the front, so it will be 5 over 2 integral of u power 4 du. So easily we can apply the rule, so it will be 5 over 2 u power 5 over 5 plus c, and we can simplify 5 cancel with 5. Then this is, so it will be and finally we are going to replace u by 8 plus x squared. Don't forget 8 plus x squared power 5 over 2 plus c. So the final answer will be 8 plus x squared all to the power 5 over 2 plus c. Let's see the last example, example 6. If we need to integrate the function of 4x squared times the square root of 2x cubed minus 8 dx. Again we have a product of two functions, and we have a composite function, because the square root of 2x cubed minus 8 like 2x cubed minus 8 all to the power half. So again we have a product of two functions, so we can integrate by the u substitution. We're going to identify u and du. U is going to be the inside function, which is 2x cubed minus 8, and du, which is 6x squared dx. Then dx is equal to du over 6x squared. Then we are going to apply the u substitution method by replacing 2x cubed minus 8 by u and dx by du over 6x squared. Then 4x squared times u power half du over 6x squared. Easily we can simplify x squared cancelled with x squared, 4, 2, 6, 3. Then we have 2 over 3 integration of u power half du easily we can apply your substitution method by adding 1 to the power. So we have u power 1 plus 2, 1 over 2 plus 2 over 2. It's gonna be 3 over 2 over 3 over 2 plus c. So we have 2 over 3 times 2 over 3. 2 over 3 u power 3 over 2 plus c. So it will be 4 over 9. We are going to replace u by 2x cubed minus 8 all to the power 3 over 2 plus c, and this is the final answer. I hope this video helped you. Thank you. See you soon.